Okay, folks. So, let's turn the camera into landscape. So, we're going to balance this equation now that we did. The that we assigned the oxidation numbers to. And the reason I'm saying to stick with this one is because it's the one we've done. We've half the work of it done here. So the steps for how to balance a chemical equation using oxidation numbers is on page 221 and page 222 of your textbook. We've actually got the first two steps done. We assigned oxidation numbers to everything. We've identified what's oxidized. Zoom back there. What has been oxidized and what has been reduced. And one more step is by how much. Okay, so in order for chlorine to go from +1 to -1, it had to gain electrons. In order for sulfur to go from +2 to -6, it had to lose 4 electrons. So we've actually got the first two steps done there straight away. So I'm going to move on onto step 3. So if you look at the original equation, okay, the sulfur actually has a number 2 here. Okay, that means in this molecule here that there's 2 sulfur atoms. Now we only worked out for 1 sulfur atom, so we have to figure that in now and reattach any subscripts to the atoms that are oxidized or reduced. So chlorine there's only 1 there and 1 on this side, so we have to just change that with the sulfur. So the chlorine doesn't change. The sulfur, however, does. We had to multiply it by 2. So it's 2 sulfurs, S2. Now it's not in front because it's a subscript. We can't touch the subscripts. Always remember that. When any balancing a chemical equation, you can change whatever numbers you want in front, but you cannot touch subscripts. So I have S2 there, so I have 2 sulfurs. Now remember, each individual sulfur atom has lost 4 electrons. So 2 sulfur atoms will therefore lose 8 electrons. So what we have here is we have to put a 2 in. Remember, again, there's no subscript of 2 up here, so we can't just stick it in willy-nilly. So we have to put the 2 in front. And this is actually helping us balance the equation, believe it or believe it not. So it's S2 this side, it becomes 2S over here. Why? Because the original equation told us to. Now, that's step 3. Step 4 now is we have to balance the electron transfer. And this is just like a simultaneous equation. So we have to make these 2 numbers equal. Okay? Now, the simplest thing to do to make these 2 numbers equal is multiply this top line by 4. Bet you're surprised. See that's clever placing of paper there. I know I'm a genius. But anyway, so we need to multiply this top line here entirely by 4. So my little brackets there. So that then becomes 4Cl plus 8 electrons will give us 4Cl minus. Now I've left out the oxygen. We don't put that in until the end. Okay? So, and the S2 bottom line doesn't change. We multiplied it by 1. And then as you can see, I kind of jumped the gun here when I was doing this. The 8 plus 8 electrons minus 8 electrons cancel each other out. And we end up with this line down here. Okay? We end up with this line down here. I'll zoom out a little bit. Okay? Now, so that's step 4. Okay? Now we're just going to reattach anything that was attached to the atoms that were oxidized and reduced. So basically, we're just going to have a look at the equation up here. Okay, have a look at this equation up here and reattach anything that we just dismissed for the moment. So in this particular case, it's 4ClO plus S2O3, 2 minus, and that gives us 4Cl minus. That doesn't change, thankfully. And then we have, what is it? Is it 2SO4? It is 2SO4. So it's 2 SO4s. Now, we're nearly finished now, folks. We're nearly finished. Now, all we're going to do then is just to put in all the other stuff that we've forgotten. So we know that this is balanced. We know this is balanced. You know, those species have to be balanced. We're just going to put in everything else that we took out of the equation. So it's, I didn't write in the SO4 here. So it's plus 2SO4 plus H plus. Okay, we've the back of this broken now, guys. So all we have to do then is balance by inspection. So we don't really have to worry about these. But anyway, let's just start it. So we have 4 chlorines. So our chlorines are balanced. We have 4 oxygens, and 3 oxygens is 7, and 1 is 8. 2 4s, 8. Perfect. So we have our oxygens balanced. Our sulfurs, we have 2 and 2. Sulfur is balanced. 1 hydrogen here, 1 hydrogen here. There we go. That equation is balanced. So, quick recap. Assign the oxidation numbers to every species. Identify what's oxidized and what's reduced, and by how much. That's the important bit. Okay? By how much. Look at the equation again and attach any subscripts and multiply by that number as such. So again, in this case, 1 sulfur atom loses 4 electrons, so therefore 2 sulfur atoms must lose 8. Okay? Then balance the electron transfer. So make the number of electrons on the top and the bottom the same, and you multiply by whatever numbers to make that happen, just like a simultaneous equation. And that's that line. The electrons will cancel, and then you end up with your equation here. So I'm probably a little bit close there. Then reattach all the bits that you forgot about on your species that were oxidized and reduced. Then put in everything else that's in the equation and balance by inspection. Okay, I hope that helps you guys. And again, if you have any questions, feel free to drop us a line. And I hope everyone is doing well and is safe and happy. And don't worry, we're all in the same boat together. And with the help of God, this will be over soon, and we'll get back to some semblance of normality. And see you later, guys. Have a good weekend.